This is a preliminary recording introducing the new quantitative vehicle routing in RouteXL. We decided to use the word quantitative rather than capacitative because capacitative is not really the right word. It refers to electricity and current and so on, whereas quantitative does refer to numbers and amounts, which is what our routing algorithm now takes into consideration. Open up RouteXL as usual. Now, you will need to work with Spatial Excel version, minor version 3.2 to work with this new version of RouteXL, and it is version 4. It's the first in the 4 series. When we release finally, it'll probably be 4.0.0.0.10 or something. At the moment, it's 4.0.0.2. So what we've done in RouteXL, we've got our usual tabs, as you can see here, and we added a tab here, quantitative vehicle routing. So we'll open that one up. So how this tab works is you can create projects, load projects, and work with projects. I'm going to show you how to create a project based on some data. It's the Durban data for that particular client we're dealing with at the moment. First thing I'm going to do is we're going to look at some points to load. Now I'm going to load, for now I'm going to load 80 points so that things don't get too slowed down. There we go, that's 80 points. To get the data into the RouteXL quantitative vehicle routing, you just copy it and you paste it in the various things. I'm looking at the points. These would be your stores, your customers. I'm calling them points to make it generic. So we paste these data on, and it brings up in the grid. Now I have the option to choose for a unique ID identifying the point. This is totally free format data that you can give it in. So I want to use the outlet name as my unique identifier. I can now specify what column in the data is going to be the demand at each point. In this case here, it is adjusted cases. I can specify from my input data what is going to be the delay at each point. This is the delay not related to how much you handling of the demand, but just the delay that is there inherently. In this case here, there's a delivery time in outlet they've got. And we will be able to, but not at the moment, specify a start time when deliveries are allowed or pickups are allowed, and an end time when they're no longer allowed. We're not using that at the moment, so we can choose none. Then we can choose a factor here which specifies how much time to add to that wait time while you're doing a delivery based upon the amount of demand. So it's just a factor which is applied to it. We're not going to use that, so we're going to specify none. Then we need to specify the locations of the columns, where the longitude is. It's these ones here, and the latitude, there it is there. We can cater for any projection, so if you do want to specify a non-default projection, the geographic projection is used by default. But if you want to specify one, you can click on the projection button and you can choose from any of the standard projections here. Okay, once you've set up these points here, we need to set up the vehicles that we are going to be using. And I've got them in a separate tab here, which I've created. It's our fleet. And I've set up some vehicles here. You can see I've given them the two types of vehicles. They each can have their own capacities. Let me just change the capacities here for these ones here. These are fictitious numbers just for the sake of our exercise, because using all the data we can use a full capacity of 50 and 100, but we're only using 80, so to make it more real I'm assuming 10 for the sprinters and 20 for the transporters. The client has 13 transporters and 32 sprinters apparently, so we've put that kind of data in. I'm going to copy this data and paste it into the vehicles tab here. Again, we can choose a unique ID, and what I've done is I've created some fictitious license plates for each of the vehicles. We'll use that as our unique ID. Now I want you to specify for each vehicle where it's starting and where it's ending. So in this routing exercise, we're starting at the depot, which happens to be the first record. So you'll notice when we work with this quantitative vehicle routing, the depots are included with your other points. Because we have to do calculations between all of them, we put them all in one point. So I've marked the first record here as outlet code as depot, and it's even got an outlet name. It's the outlet name of the client. Okay, so let's go back to our vehicles, and we're going to set the start point, which in this case here is under depot from, and the end point, which is depot 2. Now, the vehicles, they might travel at different speeds. At the moment, we can only assume the same speed for all our vehicle types. I'm looking at seeing if we can improve the algorithm, but we do have an option to choose our time factor here. I've created a time factor, it's 1, just to illustrate it. But if we do have different time factors that aren't honored by the algorithm just yet. Next, importantly, is our shift time. We've got a shift time column, so each vehicle can have its own shift time, which is, well, it's a shift time span. It's not the start is always at 0, but it must end sometime. And then your vehicle capacity, of course, we can choose that. Now, to save time and to help, before you run any scenario on that, it's going to validate for you. But I can just preempt the validation by clicking this validate button over here. I can validate my settings and it tells me they succeeded. If, for example, I didn't specify a valid longitude column, or there were nulls in the longitude column, or they were the wrong type, this validation would pick it up for us right now. Hopefully in this way we can save lots of queries and back and forths when working with new data. Okay, now the next important thing here is, well, let's show that, so this data that I've loaded so far, I've just loaded my points and vehicles. What I can do to make sure I don't lose my data later, I can save this project, so I can click the little save button here. It's going to prompt me where to save it. I'm going to save it under a file called Durban. There was one existing before. I'm going to overwrite it, and we're going to save the project. Project is now saved. Now, the first step we have to do in any of these exercises is get the system to calculate the travel times and travel distances between each of these points. In this case, it's 80 points, so it's 80 times 80 calculations approximately, which in this case is not so much, but if we get up to 1,000, it does take a while. And we might be doing up to 5,000 in some cases, and that could take many hours. You first of all need to choose, are we going for the routes between points? Are we going to try and minimize distance or time? We're going to minimize time, but you can choose either. It doesn't affect the speed of doing it. So what we'll do now is we're going to calculate the distances between the points, and we click the calculate times point button here, and it's going to do it for us. And there you can see it's doing it. Doesn't take too long considering the amount of points. Obviously, if you're going to go up to 3,000 points, it's going to take quite a few minutes and maybe hours if you go up to over 2,000. Good, there we go, the calculation is complete. So now it shows me here in this drive times distances tab, it shows me all the results. If I want to get a better display of it, I can choose what column to use to identify the points, just for this screen here. So I'll choose the outlet name, and then we can just see here, so it's going from from this particular outlet to these various points. You can actually, as you can see, if you look at the map below there, it's actually showing me the routes that it's taking. Just to, if you want to inspect your data, I can choose a whole number of them, and you'll see them being drawn. on the map as we cover them. So we literally just at this moment highlighting all the routes that go from the depot to every one of the points. You can zoom to them and get an idea. There they are. This is just for examining the data. It has no more purpose than that. One thing now, you saw it did take quite a while. We actually calculated 4,000 routes in that little exercise I did there. When you're doing thousands, it's going to take much longer, and it's going to be a lot more routes. You're going to get millions. Now these routes that are calculated are saved with the project. And when you add extra points to a project, or add a new set of points to this project, or replace all the points from this project, it will remember all the previous point-to-point calculations. So if I were to run this distance time calculation again, it would go back quickly because it remembers the old ones. Just so that when we do add new clients or points, you're not going to slow down the whole operation to generate your optimized routes later. So to give you an idea of how much data it adds to this project, if I now save this project, it's going to take a little bit longer. Because there's quite a bit of data that gets generated for the project. There we go, project saved. All right, now we've got all our drive times distances. We can now look at doing optimizations. So what this is going to do is, given these points with these demands, which is adjusted cases in this case here, here they are here. Just open it up. So these points with these demands, and given all these vehicles, so we can remove vehicles if we don't want to include them all. Given all these vehicles with their capacities and shift times and where they're traveling from and where they have to return back to, I can get it to calculate for me the best routes for all these vehicles. Now, the algorithm could take quite long depending, so there is a timeout we can specify over here. I put a timeout of 10 seconds, but it turns out for 80 points the algorithm is very, very fast. So to run the algorithm, I just click the optimize problem button here, which I'll click. And there we go, the answer came back. So you'll notice that once you've calculated your point-to-point distances, the algorithm is exceedingly fast. It worked out now a route, it said for the vehicle 0001, there's a sequence. It's going to do 8 depots, starting at the depot in Durban, it's ending the depot in Durban. It's going to visit these people here. These are the loads it's going to pick up at those people. The start time at that point in minutes, and the end time at the moment, that's what I'm working on. It's assuming my shift time, which I'm going to fix that up. Then there's another column here showing you the demand that was expected and the delay that that was experienced, the distance that was traveled from the last node, and the travel time. Okay, all the way down for each of my vehicles it does that. We can do some cross checks here. I can group by the vehicle, for example, and we can look at the demand handled by each vehicle, and you can see here that the demands add up to the capacities of those vehicles. Except for the last vehicle, because it only had a little bit left, it went down to 5. We can do those sense checks. We can look at the total travel time of each vehicle, for example, if you wanted. There's his travel time. He had longer travel time, and so on. And we can even go into the delay, separately accounted for each vehicle because of unloading and because of the delay at the depot. There we go. Now, once we've generated this output, we can quickly put it on the map by just clicking this button here. And here we go. You can see it's put these on the map. So what I can do is I can quickly just do a quick theme on colors, and we'll let the color be the vehicle just so we can see each separate vehicle route. And there we go. So we can zoom in here a little bit and go down here. There we can see our basically the routes taken by. Okay, so as you can see in our routing here, we set our shift time to be 1,300 minutes, which is way over a day. So let's try and set it to some smaller values. So what I can do on the vehicles tab here, let's try 700 minutes just as a test. A quick way to set everything to the same number is you right click on that cell and do the set all to this. Set them all to 700. And now let's rerun the scenario very quickly, and there it gives our solution. Let's just have a look at the solution and just see how it looks. We'll just drag out vehicle, and I've put some aggregates here so we can see. So here it's telling me that it's taking 454 minutes for that vehicle on its round trip, 652, and so on. So, but let's try and make it shorter. How about making it shorter? We want to get into a day actually. So let's just take off our grouping and I'll go back to our vehicles. Let's make it 480, which will be an 8-hour day. And we run the scenario, and it tells me at the bottom here, optimize failed, no solution. That's very interesting. So how come can we not get it down to 480? Well, one thing we can do, let's put it back to 700 and look at those routes and just see what is happening and why. All set to 700, and we run it. That one did work, and here we got our answer. So what we're going to do is let's look at our. We're going to look at our look at this on the map. So I'm going to first clear what was there before. We copied before. I'm removing that layer, and let's just first of all, before we look at the map, let's just see where our time is spent. Where is a long trip? Here we go. This ND10005. It's going for 691 minutes to do its trip. So let's save this. Let's save to graphics, and let's look in the graphics here and find out where that is. So it's ND. There we go. So it's quite a long route, and it looks like, yes, that is quite a long route. Well, let's just see what it says here about the time. Wait time. Okay, good. Distance demand. Okay, well, let's get an idea. Let's use our other routing tool here to see how long it takes anyway to drive this whole route. So we'll click from here, Lusiki, where it's going to, approximately back to the depot, approximately. And it tells us that it's going to take 302 minutes just to go one way. So, well, that shows you then to service all these customers with that shift time from that depot is not possible in under 600 minutes at least, if you look at this. So, and that is not even taking into account the in-store time or the delay time. So anyway, so the model told us here that we can't service all these customers with these vehicles and with these shifts with these numbers.